Okay, good afternoon, everyone, and glad to see you all, the speakers, and today some of you was my friends and long time since we have a pandemic, we are not see each other, Pak John, and let me before we start the presentation. Let me introduce all the speakers. And first of all, I would like to thanks to the speaker and participants who have attended this forum. And today topics of our discussion is about the building and household. And we'll present 4 expert speakers who will share their experiences and knowledge with all of us. The speakers will be allocated for 15 minutes each, and please make the most of the available time efficiently. And then followed by a Q&A after all the presenters finish their present, and will be conducted as much as the rest of the time that we still have at the end of the session. And for participants who want to submit a question, please use the available chat facilities that already prepared, already provided by the committee. And allow me to introduce our speakers today. First, we have Dr. Insinyur Surjamanto Wonoraharjo, MT. He is a lecturer at Bandung Institute of Technology with a study area of building materials technology, urban thermal environment. He currently serves as a head of the ITB Innovation Area Division. He has produced several technological works and 3 of them have received patents, namely air conditioning box and panel, outdoor wall thermal insulation layer based on newspaper recycled materials, and thermal insulation material based on mixture of conhusk and epoxy waste. He is also a reviewer in various international journals. The next speaker will be Jeswynn Yogaratnam, and he is a trained lawyer in corporation and international human rights law. He holds an LLB, Honors, and Master of Law in Taxation. He expertise in policy development and policy reform applying international human rights law and SGD principles to move the dial in climate security. Currently, Jeswynn Yogaratnam is managing strategic engagement and policy development for the carbonization programs in Southeast Asia and India, applying life cycle and co-benefit approach. A trained lawyer, law academic, and also researchers in interdisciplinary areas of law and human development. He is also managed a program that promotes change management based on ESG principles that initiate internal reform strategies to enable private, public, and also non-profit sectors to become part of the solution to carbon abatement goals. Interested in the embodied concept of the built environment applying a people-centered approach and principle-based responsive regulation. Jeswynn Yogaratnam also now currently head of a policy reform to the Global Building Performance Network, or GBPN. The third speaker is Pak John Budi Halistiono. He has 35 years of experience in APAC field as a businessman, lecturer, advisor for the government institution. He is also involved in developing APAC technical standards and guidelines. He has also been appointed as a judge for many EE competition in Indonesia and ASEAN, and he is active in several EE professional organizations. With his long journey and experiences, he has earned He has earned 3 APAC patents in Indonesia and 1 APAC patent in Australia. The next speaker will be Anne Svensson. Anna is a special advisor to the Danish Energy Agency, DEA, on energy efficiency in building. She holds a master's degree in energy efficiency in the built environment from the Cranfield University of Technology in the UK. She has worked with energy efficiency in building for more than 20 years. She is a certified BREEAM, BREEAM, and DGNB consultant. Mrs. Svensson is working on creating and sustaining a transition to the global clean energy economy based on Danish experiences. The goal of the Danish Energy Agency is a well-planned green transition with Denmark leading the way, sharing the Danish experiences and solutions globally on energy efficiency in building and industries, renewable energy, and also sustainable transportation. So those the brief introduction to the speakers. I think we have very prominent speakers today. And now let me cordially invite Mr. Surjamanto Wonoraharjo to take the stage. Pak Surjamanto will convey about the sustainable building materials development. Of course, I would like, it would be very interesting to know how building materials affect the performance of a building in countering environmental issues and also contributing to the EE. Time is yours, Pak.
Thank you, Ibu Farida. Apakah sudah terlihat?
Sudah, Pak.
Baik, terima kasih Ibu Farida sudah memperkenalkan saya. Izinkan saya menyampaikan dalam bahasa Indonesia.
Monggo, Pak, monggo.
Ya. Selamat siang Bapak Ibu semua. Salam jumpa. Perkenalkan, saya Surjamanto Wonoraharjo dari ITB. Hari ini saya ingin berbagi tentang hasil-hasil studi saya tentang bahan-bahan bangunan berkelanjutan. Dalam presentasi ini, saya ingin membahas berbagai alasan untuk mempelajari bahan bangunan berkelanjutan, dan kemudian apa saja masalah yang muncul terkait dengan bahan bangunan tersebut. Dan kemudian yang ketiga adalah arah-arah dan prospek dalam studi bahan-bahan bangunan berkelanjutan. Seperti kita ketahui, pada topik pertama ini saya akan menyampaikan bahwa banyak sekali alasan ya mengapa kita perlu mendiskusikan sustainable building material begitu. Antara lainnya adalah degradasi lingkungan begitu, dan terkait dengan krisis energi. Ya, ini sudah kita sadari pada SDGs ya, Sustainable Development Goals ya. Ada banyak alasan lain untuk membahas keberlanjutan, antara lainnya seperti kesehatan, sumber daya alam, budaya, ekonomi, sosial, hukum, keadilan, kesetaraan ya, gender ya, justice dan lain-lain begitu. Pada sesi presentasi sore ini saya ingin menyampaikan nilai strategis bahan bangunan dalam pembahasan sustainability, dalam pembahasan keberlanjutan. Setiap bahan ini memiliki nilai strategis ya. Setiap bahan memiliki nilai kegunaan. Kayu, baja atau beton, batu, aspal, kaca, PVC atau bahan-bahan lainnya umumnya banyak digunakan pada bahan bangunan. Ada beberapa keuntungan. Ada nilai keuntungan menggunakan bahan. Sebagai contoh misalnya bahan beton pada bangunan. Portland semen seperti yang kita kenal sekarang banyak mengandung kapur Dia adalah sumber daya alam Indonesia yang melimpah. Indonesia mempunyai banyak kapur yang bisa dipakai sebagai bahan baku untuk pembuatan semen. Pemanfaatan sumber daya alam lokal ini merupakan nilai lingkungan, environmental value yang penting, yang sangat baik untuk mendukung sustainability dalam bahan bangunan atau keberlanjutan bahan bangunan. Selain itu, bahan-bahan bangunan juga mempunyai nilai lain. Selain kegunaan, kemanfaatan, ya nilai-nilai praktis, juga mempunyai nilai-nilai ekonomis, ya, di mana bahan bangunan ini adalah bisnis yang besar, ya, baik perdagangan lokal maupun internasional. Bahan bangunan ini merupakan komoditi yang sangat menarik, yang menggerakkan perekonomian, baik perekonomian negara maupun dunia sampai saat ini. Selain itu, material ini juga mempunyai nilai sosial, di mana orang-orang yang mempunyai kelas ekonomi tinggi tentunya akan memilih bahan-bahan bangunan yang lebih berkualitas, lebih mahal, dan tentunya lebih baik penggunaannya begitu. Dengan demikian maka kita bisa memandang bahwa material ini mempunyai banyak perspektif, banyak nilai yang bisa dimanfaatkan begitu. Kita tidak bisa melihat material sebagai material saja, tetapi kita melihat material sebagai satu yang mempunyai banyak sudut pandang begitu. Ini adalah showroom dari material. Saya selalu mengagumi tahun ada banyak dipamerkan bahan-bahan bangunan baru yang lebih baik, lebih murah, lebih menarik, lebih mudah untuk dibangun begitu. Dan ini akan mendorong pergerakan ekonomi pasar. Mereka punya target pasar mana yang akan disasar. Mereka akan mencari pangsa-pangsa yang paling menguntungkan. Oleh karena itu menguasai ilmu bahan, menguasai material ini sangat penting bagi perkembangan ekonomi suatu bangsa. Berbagai isu tentang ekonomi yang menyertai bahan-bahan bangunan ini tidak kalah juga isu negatif dari material tersebut, antara lain waste, ya, sampah dan limbah, ya. Kita mengenal ada berbagai macam limbah, ada limbah padat, limbah cair, atau limbah gas, ya, gas emission, limbah gas buang. Selain limbah yang kita kenal, ada juga limbah yang tidak langsung muncul akibat penggunaan bahan bangunan. Saya menyebutnya sebagai heat waste. Seperti yang kita ketahui bersama bahwa beton dan batu bata adalah dua bahan bangunan yang paling populer di Indonesia. Penggunaan bahan-bahan tersebut berpotensi melepaskan panas atau kalor ke udara. Bahan-bahan beton, batu bata dapat menyerap kalor dari sinar matahari, lalu melepaskannya kembali ke udara dan menimbulkan pemanasan. Ini yang saya sebut dalam tanda kutip ya sebagai limbah kalor yang dikeluarkan oleh bahan bangunan akibat penggunaan bahan tersebut begitu. Ini adalah salah satu buku saya tentang bangunan gedung hijau, ya, di mana ada sebuah gedung yang diambil gambarnya dengan kamera inframerah dan pada pukul 8 pagi, ya, menunjukkan bahwa gedung itu lebih tinggi temperaturnya dibandingkan lingkungan sekitarnya. Hal ini menunjukkan bahwa penggunaan bahan-bahan bangunan yang berat seperti beton dan batu bata ini menimbulkan limbah buangan, ya, kalor ke udara begitu, ya. Beberapa waktu yang lalu kami mengadakan pengukuran di Kota Bandung dalam radius sekitar 100 meter persegi mungkin 100 meter dalam radius 100 meter. Kita menghitung berapa besar penggunaan batu bata, beton, berapa penggunaan kaca, dan berapa penggunaan aspal begitu, ya. Sangat mengejutkan ternyata penggunaan batu bata dan beton ini paling banyak dibandingkan dengan penggunaan bahan-bahan yang lain. Ini kita hitung dari total penggunaan bahan bangunan pada berbagai jenis kawasan begitu. Nah, di sini kita tunjukkan bahwa penggunaan bahan-bahan bangunan tersebut menimbulkan lingkungan termal yang berbeda begitu ya. Bahan-bahan bangunan tersebut melepaskan limbah kalor begitu ya. Pada penggunaan batu tempel pada kolom bangunan ini menyebabkan pemanasan yang lebih pada lingkungan sekitarnya. Di sini batu-batu tersebut menyimpan kalor dan melepaskannya kembali ke udara. Kita lihat di sini pada contoh lain, aspal juga melepaskan kalor dalam jumlah banyak, genteng juga melepaskan kalor dalam banyak, serta dinding-dinding bata juga melepaskan kalor dalam jumlah banyak. Dalam skala yang lebih jauh, dalam sudut pandang lebih tinggi, maka kita bisa melihat kota sebagai konfigurasi susunan dari material bangunan yang melepaskan kalor ke udara dan mana yang tidak begitu ya. Di sini terlihat bahwa jalan-jalan dan bangunan-bangunan besar yang menggunakan bahan-bahan bangunan berat itu melepaskan kalor ke udara cukup besar, sehingga dalam pandangan kamera infrared ini terlihat bahwa kota ini menghasilkan panas atau kalor yang membuang kalor berlebihan ke udara. Bapak Ibu sekalian yang kami hormati, di sini kami menyampaikan satu fenomena urban heat island. Kajian ini sudah kami laporkan pada jurnal di tahun 2020. Kita membahas bagaimana penggunaan berbagai jenis bahan dinding, kemudian kita lihat efeknya pada pemanasan lingkungan. Pada percobaan kami, pengukuran kami di dalam laboratorium, kita melihat bahwa brick wall itu menyerap kalor dalam jumlah banyak, kemudian meneruskan ke dalam ruangan. Sebaliknya, jenis tipe dinding yang lain, yaitu sandwich wall, dinding yang berlapis insulasi, ini menahan sinar matahari tersebut, menahan radiasi kalor tersebut, masuk ke dalam bangunan, sehingga di dalam bangunan itu menjadi lebih dingin. Tetapi, panas tersebut terkumpul di permukaan dan dilepaskan kembali ke udara. Hal ini memberikan efek yang sama buruknya, ya, dengan penggunaan batu bata. Jadi baik brick wall maupun sandwich wall itu bisa memberikan efek yang negatif pada lingkungan, baik indoor maupun outdoor, baik ruang dalam maupun ruang luar. Hal ini kami tunjukkan dengan simulasi tersebut bahwa penggunaan batu bata yang di sebelah kiri itu menunjukkan bahwa kalor itu dibawa masuk ke dalam ruangan. Sedangkan pada penggunaan sandwich wall pada bangunan di sebelah kanan, kalor tidak dibawa masuk ke dalam bangunan, tapi dilepaskan keluar, sehingga intensitas urban heat island atau intensitas peningkatan temperatur udaranya lebih tinggi pada penggunaan pada kawasan dengan menggunakan bangunan-bangunan yang menggunakan bahan sandwich wall. Hal ini menunjukkan bahwa material berpengaruh pada kualitas lingkungan. Hal ini kita sebut dengan thermal behavior dari bahan-bahan bangunan. Baik, Bapak Ibu, kami beralih pada aspek ketiga, yaitu prospek dan arah-arah bagaimana kita merancang bahan bangunan itu yang benar. Bagaimana secara bijak kita menggunakan bahan-bahan bangunan. Pada slide ini saya ingin menunjukkan bahwa kita manusia itu adalah bagian dari environment. Kita adalah bagian dari environment, di mana di dalam environment tersebut, built environment mengeluarkan emisi gas buang, kemudian diserap oleh berbagai tumbuhan. Tetapi bila tumbuhan ini hilang, maka kitalah anak-anak kita, saudara kita, keluarga kita yang menyerap udara atau emisi gas buang. Demikian juga dengan limbah kalor yang dibuang. Di sini saya ingin menyampaikan ada beberapa konsep. Yang pertama adalah life cycle konsep. Kita mengkritisi bagaimana penggunaan material tersebut, ya, secara bijak begitu, dengan memperhatikan life cycle-nya. Penggunaan bambu sebagai contohnya, yang setelah 3 bulan atau 3 tahun kita tanam, kita bisa panen, kemudian kita gunakan sepanjang 60 bulan. Bila kita sudah tidak menggunakan bambu itu lagi, maka kita bisa buang dengan mungkin setengah bulan sudah dapat terurai kembali ke alam. Namun apabila bambu tersebut ya kita perkeras, kita beri warna, kita awetkan, kita beri perlindungan dan lain-lain, ini membutuhkan biaya dan mempunyai nilai jual, nilai ekonomis yang tinggi. Contohnya parket untuk lantai, begitu ya. Dan dia bisa digunakan 10 tahun. Namun, keuntungan ini harus dibayar oleh lingkungan. Bila bahan ini dibuang, dia membutuhkan waktu yang jauh lebih panjang dan membutuhkan biaya yang jauh lebih banyak untuk mengurainya. Oleh karena itu, penggunaan bahan-bahan yang sudah diawetkan dan diolah ini menjadi tidak sustainable, begitu ya, atau mempunyai masalah dengan lingkungan. Baik, berikutnya kami menyampaikan, lalu bagaimana penggunaan konsep teknologi yang benar begitu ya. Di sini saya menyampaikan beberapa konsep hasil pemikiran bagaimana teknologi yang tepat yang bisa kita gunakan untuk menjamin sustainability dari bahan-bahan bangunan. Kita membutuhkan teknologi baru. Saya menyebutnya pasangan teknologi begitu ya. Apabila kita sudah mempunyai teknologi untuk mengcombine, mencampur material, maka kita membutuhkan teknologi untuk melepas, mengurai material tersebut. Apabila kita mempunyai teknologi untuk melepas kalor, maka kita membutuhkan teknologi untuk menangkap kalor tersebut. Demikian juga kita bila mempunyai teknologi yang melepas karbon dioksida, maka kita memerlukan teknologi yang mampu mengumpulkan karbon dioksida atau karbon dioksida tersebut. Ini adalah tantangan, challenge, prospek atau arah yang dibutuhkan untuk pengembangan teknologi-teknologi baru. Nah, saya menyampaikan hal ini sebagai arah atau prospek bagi pengembangan sustainable building material atau bahan-bahan bangunan berkelanjutan. Sebagai contoh, di sini kami mengembangkan satu produk yang menggunakan konsep thermal balance dari air conditioner, begitu ya. Sebagaimana kita ketahui bahwa kita menggunakan aircon atau air conditioner, begitu ya, yang mendinginkan udara menggunakan energi listrik, tetapi mengemisikan kalor ke udara, begitu ya, sehingga kita tidak bisa mempertahankan temperatur lingkungan kita tetap sejuk dan lama. Saya menggunakan konsep thermal balance di mana kita menyerap kalor pada siang hari dan melepasnya pada malam hari menggunakan PCM atau phase change material sebagai internal thermal mass yang diletakkan di dalam ruangan. Hasil penggunaan air conditioner ini menunjukkan penurunan udara yang signifikan pada berbagai ketinggian di dalam ruangan. Di sini saya mengukur temperatur udara di ketinggian 30 cm, 90 cm, 150, 210, dan 270 cm. Penggunaan internal thermal mass dari PCM tersebut bisa mengurangi, menurunkan temperatur udara secara signifikan, begitu. Oleh karena itu, penggunaan konsep-konsep yang benar dengan memanfaatkan teknologi material, pemahaman terhadap phase change material, sifat smart material yang material pintar, secara bijak bisa di dalam lingkungan binaan kita mengenerate suatu lingkungan binaan yang berkelanjutan. Bukan hanya bahan bangunan saja yang berkelanjutan, tetapi lingkungan binaan yang berkelanjutan. Saya rasa ini adalah akhir dari presentasi saya dan hasil pemikiran tersebut, hasil-hasil studi tersebut telah kami publikasikan pada berbagai jurnal, buku, dan paten. Demikian dari kami, terima kasih. Bila ada pertanyaan atau ingin melakukan kolaborasi lebih lanjut, silakan menghubungi kami di email ini. Terima kasih, saya kembalikan kepada Ibu Farida.
Terima kasih, Pak. I really enjoy your presentation, and we will have discussion time afterward. Dan for the next speaker, I would like to invite the second speaker, Mr. Jeswynn Yogaratnam, to deliver her his presentation. He will explain about EE in residential building. It would be interesting to know what the challenge of the implementing EE in residential building. I'm sure your presentation add insight to all of us today. Jeswynn, please, time is yours. Yes, the material already appear in the screen. Yoga, are you okay? Yes, please. You still mute? The song. Please do check your microphone, Yoga.
Is working?
Yes, now working.
Okay. Selamat siang, Ibu Farida, Ibu Gunabawa sekalian. Good morning, good afternoon, and good evening to all who's listening to this presentation. First, I'd just like to acknowledge the Wurundjeri people and the traditional owners of land from where I'm transmitting this presentation here in Melbourne, Victoria. And I pay my respects to the elders past and present in relation to all the teachings on sustainability that the Aboriginal community here in Australia have brought to us. I also like to acknowledge MASKEEI, and in particular John Respati, who has been instrumental in bringing this collaboration together with GBPN, and also our colleagues in Indonesia, GBPN's colleagues, Ibu May Batubara, who has been working diligently behind the scenes with the MASKEEI team to bring this together. The topic of my presentation today is law and regulatory policy reform, the way forward to building back better. Clearly, in my presentation, as opposed to many of the others today, and perhaps after me, it does not focus on technical merit, but rather on the other side of the coin that requires technical merit to become operational through law and regulatory policy reform initiatives. As a response to the theme of this conference, I'd like to just put this, because I noted that the theme of this conference is on EV, electric vehicles. And I want to say that you are not stuck in traffic, you are traffic. I also want to say you're not stuck in traffic, you are traffic in the context of law and regulation, because sometimes law and regulations create a traffic in terms of policies that don't align with each other and are not coordinated with each other, which actually creates a bit of a jam in terms of implementation, some of those great technical merit decarbonization policies that we need to come into effect. The scope of my presentation will generally be along these 6 areas, and I hope I can cover all 6. If not, please do ask me questions during Q&A. The first part is, what are the international law policy goals for energy efficient residential buildings based on? Then I'd move on to cover what are international perspectives in this area. Then more importantly, why is law and regulation and policy reform important? And then I'll move on to where are the local provisions found by using Indonesia as a case study. Following that, I'll unpack some of the law reform that GBPN has trying to operationalize as part of our policy strategies. And hopefully towards the end, I'll get to how to be question in terms of what are the international law policy goals for energy efficient residential buildings based on. And this is something we need to take into account when we are policy making and we are also developing regulations and law. Now, essentially, when there's something called international law and domestic law, and many of the provisions in the context of domestic law are based on some of these international principles found, for example, the Universal Declaration of Human Rights of 1948. And one of the things you'd find is the right to adequate housing. Now, we need to understand that when we talk about the right to adequate housing in today's context, and especially in the context where we're living in pandemic, where we are at home most of the times, there is a need to sort of understand the decarbonization and life cycle aspects of the housing in order for that home to be considered to be a healthy home for the individual and families. So this is a concept that's already been in the international realm since 1948, but to contextualize it in today's context, the right to adequate housing, I am saying as part of GBPN that it also includes all those energy efficient imperatives, all that technical merit that Pak Sujarmoto had earlier mentioned. Also, some of the goals come from the Sustainable Development Goals, which we are quite aware of. In particular, you will note, for example, in SGD 11, it talks about to make cities and human settlements inclusive, safe, resilient, and sustainable. And of course, you've got SGD 13, where they said take urgent action to combat climate change and its impact by regulating emissions and promoting developments in renewable energy. So at a local level or at a national level, when we talk about trying to achieve some of these images that you see here on the screen in terms of what an energy efficient house may look like, we are actually enabling some of these international provisions to come into application. So when we policy make or law make in this area, we need to take into account where the source is, and the source comes from some of these international legal instruments. Clearly, for all of us that are here and engaged with this session, we are quite familiar with the Paris Agreement, and we know about the 2030 zero carbon solution, which has become a competitive area in all sectors, representing over 70% of global emissions. The important point here is that by 2030, zero carbon solutions could be competitive. And when we say competitive here, it's not just competitive in terms of the technical merit, but competitive in terms of policy making, regulatory making, and law creation in this space to enable all those decarbonization imperatives to actually come to life at the city level, at the state level, and of course, clearly at national levels to achieve those NDC targets. Moving on to the next question in terms of what are the international perspectives. Now, over the weekend, we just went through this whole G7 meeting, and the world came across a number of really good ideas that were put forward. The G7 came up with what you call global action to build back better. And clearly, some of the global action to build back better, as noted by Climate Works Australia's post here, is in relation to what they had agreed to, which was to end government support for coal power by the end of 2021. The question then is, in coming to that sort of resolution, how do we end it? We need to end it by enabling certain regulations to come into place to enable all these supply chain entities and other relevant organizations to come along with you. To come along with you through the regulatory processes, through the policy reform that's put in place in relation to this area. In the G7, you also noted that a specific area in relation to homes and buildings. And there was specific mention in para 38 that to be credible, ambitious, we need to be supported by tangible actions. Tangible actions does not only mean in terms of the technical merit, but also in terms of some of those policies that need to be reformed in order for that technical merit imperatives to come into action. For example, here they've noted the super efficient equipment and appliance deployment initiatives. Now, how can these initiatives come into application without regulatory reform, without some aspect of law reform, which I will get to shortly? Other international perspectives come from the IFC, where in the most recent report, the Green Buildings Finance and Policy Blueprint for Emerging Market, the director had noted that if you build green buildings open the door to better business and cleaner world. Importantly, it was noted that green buildings represent one of the biggest investment opportunities in the next decade, 24.7 trillion across the emerging cities. This is an important point to note in terms of, in order to attract investment, you also need to have regulatory reform in order to ensure there's some form of investor confidence. In that report also, it was noted that a lack of alignment of incentives and benefits among market players and the mismatch between in this space can be some of the indicators that slow down movement into the green building space. My response to this would be, it's because the regulations have not come up to speed, or the law has not come up to speed in terms of enabling that alignment of incentives. And one of the speakers earlier today talked about incentives in the context of financial incentives and non-financial incentives in terms of what HSBC has put together. This can only come about in a impactful way if the regulations and law march alongside some of those great ideas that financial institutions are putting together.
Excuse me, Yoga. Can you move the slide?
Yep.
Then the participant can follow your presentation.
Yes, I'm moving the slide. Is it not moving?
No.
I have moved it on my side.
Okay.
Is it moving?
Now we cannot see.
It's moving on my end, so I'm not sure. Okay. Is it moving on your end?
There is appear. It's not appear.
Okay, it appears on my end, so I'm not sure why it's not appearing on your end.
Okay, okay. Please continue. Yes, we can hear.
Can you see the slides?
Yes, yes. Slide number 9, right?
No, I'm slide number 13 now.
Oh, it's still 9.
Okay.
Yes.
Okay, I'll perhaps mention the slide number so you can change accordingly. So just moving on in terms of why the international perspectives, you also note that the ASEAN Center of Energy has also reported on, in Jakarta, for example, there's been a reduction on taxes on low emission vehicles. And why am I talking about vehicles in the building context? Because when you look at the whole concept of a smart building, it's a building that also enables vehicles to have that imperative of i.e. the electric vehicles being charged. So this is an important point because it's regulations and law that enable these sort of buildings to promote these sort of buildings, because in order for these buildings to come about, there need to be certain regulatory changes. For example, the building authorities need to sort of make certain amendments to some of their regulations at a local level for that to happen. I'm just moving on to slide 14 now. So slide 14 really looks at why is law and regulation and policy reform important. Now, it is important because it enables national and subnational governments to policy plan, policy adopt, and policy implement to activate and mobilize the relevant law regulations. It becomes a push factor to decarbonize the residential sector, the residential building sector. So law and policy becomes this push factor, and it's something to note. Importantly, it provides investor confidence. Certainty and clarity of the law is so important for investor confidence. It also then incentivizes the private sector, and clearly it leaves no one behind, because when you have law and regulations that are in place that covers all the multi-sectoral entities, i.e. the supply chain, government, and all the other relevant sectors that are within this space, you are actually leaving no one behind, and the transitionary measures will enable this process to come through to a people-centered approach. It will also then enable harmonization of international and domestic instruments, which is really important for achieving those the NDC targets that are put upon by each country. Importantly, from a domestic perspective of each country, it creates jobs and stimulates economy. And importantly, I think the other point that I want to note is that in order for roadmaps on energy to be efficient and to work, it needs to also be cognizant of the branches of law that can make technical merit of energy policy to be better implemented. So the roadmaps on energy need to have branches that actually map out the law all the way to a city level to the national level to how it then relates to the international obligations that that particular jurisdiction has signed up to. Moving up to slide 15. So why is law and regulation also important? Because today, as Ibu Dian had said from the Ministry of Public Works and Housing, in Indonesia, for example, you have these new building laws, but in order for it to have effect, certain regulations need to be put in place. And Ibu Dian talked about Regulation 2021 that is going to bring about some level of change in terms of green buildings. Moving on to the next slide. Also, in the recent IEEE webinar, it was made clear by the speakers, especially the speaker speaking on the financial incentives, where new regulations are required in order to enable those financial regulations to come into effect. And also, as noted by experts in the field, when a question was put in terms of energy efficiency for net zero carbon, the response by another expert was that looking forward to more legislation enforcing EE, because it seems that the basic existing payback period is not sufficient in motivating investors. So clearly, the point being that legislation is important in this space in order to move that dial on a local level. We've also seen other organizations like Climate Works Australia in Indonesia talking about raising Indonesia's net zero ambition and the pivotal role of energy systems in setting standards and reaching the zero target. And in this instance, clearly, we've noted how it is important for the Ministry of National Development Planning and the Ministry of Energy Resources to come together in a kind of like a whole of government approach to address the issues of state-owned electricity PLN in order to push existing scenarios to hope to hit that net zero closer to 2050 targets. So this is why regulations and reform is important. We've also noted from the Climate Works report, which takes on some of the data from Indonesia in relation to developing clean energy and electricity, enabling conditions to maintain the percentage it needs to through regulatory reform. The other slide, this slide basically goes to demonstrate the investment minister Bahir Lahadalia in a statement where he said did not specify a time frame. Now, when we hear statements where timeframes are not specified, it is essentially also because the law and policy in relation to this space has not yet developed, which goes back to the question: that in terms of technical merit coming to being, what do we need? We need law and regulation in place to make it work. As a case study with Indonesia, where has this moved forward?
Yoga, excuse me, time is out for you.
Thank you. So as the last slide, I'll just take note of some of the law and regulation that is passed in Indonesia in relation to green building policies. And as you'll note, it's because of these laws and regulations that have been passed that have enabled some of the green building projects and programs to move forward. And we hope that with further policy reform, with the work that GBPN is doing, with local government and all the other bodies in Indonesia, we see more law moving towards green building policy making. Thank you.
Thank you, Yoga. Very interesting presentation. And we will wait till the end of the session to have a Q&A afterward. And I would like to invite the third speaker, Mr. John Budi. He will explain about the tropical building design for health and energy efficiency, which is very relevant to the current condition of COVID-19 that we are facing. Please come forward, John. Time is yours.
Sudah kelihatan, Bu?
Sudah, Pak.
Saya pakai bahasa Indonesia aja ya.
Monggo, Pak, monggo.
Oke, selamat siang Bapak-Bapak, Ibu-Ibu sekalian. Siang ini saya akan membahas masalah mengenai tropical building design for health and energy efficiency. Di sini ada tiga pokok masalah, yaitu pertama adalah apa itu tropical building. Lalu yang kedua itu adalah mengapa itu health, dan yang ketiga adalah mengenai energy efficiency. Nah, sebelumnya saya memperkenalkan diri saya. Nama saya adalah John Budi Haryanto. Saya fellow ESRE. Saya bekerja di 2 perusahaan, PT Metropolitan Bayu Industri dan PT Solusi Udara Tropis. Oke. Kita akan membahas masalah mengenai ketiga masalah tersebut. Jadi ada tropical building, ada healthy, dan ada energy efficiency. Pertama, kita melihat dulu masalah ini kita hadapin ini. Bahwa dengan adanya pandemik ini, maka semua orang sekarang sudah sadar bahwa kesehatan itu adalah menjadi satu-satunya yang paling utama. Bukan lagi mengenai energi, bukan lagi mengenai air, bukan lagi mengenai material dan lain sebagainya yang selama ini digaungkan oleh green building. Tetapi adalah masalah kesehatan. Nah, sekarang ini kesehatan ini semuanya itu arahnya ke arah healthy building. Karena apa healthy building di sini? Kita tahu bahwa hampir building-building yang ada, baik itu di Indonesia maupun di dunia itu, tidak didesain untuk menghadapi pandemik ini. Mengapa tidak didesain untuk menghadapi pandemik ini? Nanti kita akan jelaskan lebih detail. Nah, bagaimana untuk mengatasi yang pandemik ini? Salah satu adalah dengan mengintroduce udara luar. Jadi udara ventilasi itu dimasukkan. Nah, kalau misalnya kita memasukkan udara luar ke dalam bangunan tersebut, maka kita harusnya itu mendesain suatu bangunan itu tidak lagi dengan memakai konsep seperti konvensional thermal comfort sekarang ini, tetapi kita harus sudah memakai adaptive thermal comfort. Nah, kenapa kok adaptive thermal comfort ini yang dipilih? Karena dengan adaptive thermal comfort ini bisa menangani masalah mengenai healthy building dan juga bisa menangani mengenai energy efficiency di dalam building. Nah, nanti kita akan menjelaskan masalah mengenai yang paling cocok di Indonesia ini bangunan yang gimana. Karena Indonesia ini adalah di khatulistiwa, jadi Indonesia adalah termasuk tropical building. Jadi nanti kita mengenai tropical building, healthy building, dan energy efficiency building. Kalau kita memperhatikan riset-riset selama pandemik dan sebelum pandemik, itu banyak sekali riset-riset yang sudah kita dapatkan. Konsentrasi CO2 yang ada di dalam suatu ruangan itu sangat mempengaruhi kesehatan seseorang yang ada di dalamnya. Harvard University itu mengadakan suatu riset, ternyata mereka mengatakan kognitif otak dan juga konsentrasi produktivitas seseorang yang ada di dalam building itu tergantung dari konsentrasi daripada CO2 yang ada di dalam building. Tahun yang lalu, dan papernya itu baru publish pada tahun 2021, salah satu Profesor Chandra Sekar dari Singapura, itu mengadakan suatu research bahwa apabila konsentrasi CO2 di dalam ruangan untuk orang yang sedang tidur, apabila konsentrasinya di bawah 750 ppm, maka tidur orang tersebut itu akan nyenyak. Makin tinggi konsentrasi daripada CO2 di dalam ruangan, maka makin tinggi kegelisahan orang tersebut dan malah tidak sehat. Menyebabkan setelah bangun tidur, itu merasa badannya itu tidak nyaman disebabkan karena konsentrasi CO2 yang tinggi. Nah, demikian juga ada hubungannya antara CO2 dengan udara luar dan ada konsentrasi O2. Nah, konsentrasi O2, makin tinggi konsentrasi O2, itu kita dapatkan dengan memasukkan udara luar yang lebih banyak. Dengan memasukkan udara luar lebih banyak, konsentrasi CO2-nya ini bertambah kecil. Nah, menurut Dr. Otto, pemenang hadiah Nobel 2 kali, semua penyakit-penyakit degeneratif manusia seperti diabetes, tekanan darah tinggi, jantung, Alzheimer, dan lain-lainnya, itu semua disebabkan karena kekurangan oksigen. Nah, terutama apa? Terutama pada waktu saat kita tidur. Karena kita tidak sadar bahwa kita tidur adalah 6-8 jam, di mana apabila kita memakai suatu AC yang tidak ada udara luar yang kita masukkan, maka menyebabkan konsentrasi O2 di dalam ruangannya itu bertambah jelek. Dan kenapa sekarang ini banyak sekali orang-orang modern yang terkena penyakit degeneratif. Ini salah satu penyebab adalah disebabkan karena kekurangan oksigen. Nah, menurut ASRI Standard, bahwa selama pandemik ini udara luar yang harus dimasukkan ini minimum adalah 2 kali ACH, air change per hour, daripada volume ruangan. Nah, kita tahu hasil riset juga ternyata COVID-19 yang dikeluarkan itu termasuk bioinfluence yang dikeluarkan oleh manusia yang ada di dalam ruangan tersebut. Nah, konsentrasi bioinfluence ini sama dengan jumlah konsentrasi CO2 yang ada di dalam. Makin tinggi konsentrasi CO2-nya, maka bioinfluence ini juga makin tinggi. Karena kedua-dua zat ini dikeluarkan oleh orang yang ada di dalamnya. Kita bernafas, kita mengeluarkan CO2, kita juga mengeluarkan zat-zat yang disebut bioinfluence concentration. Jadi, untuk mendapatkan suatu bangunan yang healthy, maka konsentrasi CO2 di dalam ruangan tersebut itu harus serendah-rendahnya. Dulu Green Building mengatakan bahwa konsentrasi CO2 itu cukup 1000 ppm. Tetapi untuk healthy building, sekarang riset yang terakhir mengatakan bahwa konsentrasi healthy building harus mempunyai konsentrasi CO2 harus kurang dari 800 ppm. Nah, kita bahas sedikit mengenai thermal comfort. Thermal comfort di sini dipengaruhi oleh 6 parameter, yaitu temperatur, kelembapan atau RH, airspeed, pakaian yang dipakai, metabolisme, dan yang disebut dengan radiant mean temperature yang ada di dalam ruangan tersebut. Nah, ini adalah konsep-konsep yang dikembangkan oleh McPherson pada tahun 1962. Kalau kita misalnya memperhatikan sekarang ini ternyata banyak sekali gedung-gedung yang mempunyai iklim yang berbeda, itu temperaturnya itu tidak selalu sama dengan yang konsep dengan thermal comfort di sini. Maka berkembanglah suatu konsep yang kita sebut dengan adaptive thermal comfort. Nah, apa itu adaptive thermal comfort? Adaptive thermal comfort ini memasukkan unsur-unsur daripada temperatur udara luar, lalu behavior orang tersebut, psikologi orang tersebut, semuanya itu dimasukkan. Nah, itu risetnya itu adalah dimulainya itu adalah tahun 78. Ini adalah ASRI Standard tahun standar 55 tahun 2017. Kotak merah itu adalah untuk daerah tropis yang nyaman menurut thermal dari ASHRAE standard, yaitu temperaturnya dari 23 sampai sekitar 27 dengan RH-nya itu dari 40% sampai 60%. Ini adalah menurut konsep thermal comfort konvensional. Tetapi sekarang ini banyak sekali ini sudah berkembang dengan memakai adaptive thermal comfort. Dengan adaptive thermal comfort di sini, maka temperatur daripada ruangan itu kita bisa naikin. Nah, tahun 2019, Kajima bersama-sama dengan Singapore University mengadakan suatu research untuk memakai suatu adaptive thermal comfort, yaitu mereka memakai DOAS dan ceiling fan. Hasil dari research mereka, temperatur yang ada di dalam ruangan tersebut bukan lagi 24,5, tetapi bisa dinaikkan menjadi 27,5 sampai 29, dan saving energinya itu bisa lebih dari 25%. Nah, ini saya lewatin aja. Ini adalah konsep yang dikembangkan dulu untuk conventional thermal comfort, yaitu memakai PPD, yaitu predictive percentage dissatisfaction, ketidaknyamanan, sedangkan yang satunya lagi predictive mean fault, yang merasa nyaman. Saya teruskan lagi. Nah, bagaimana perkembangan dari adaptive thermal comfort? Ini adaptive thermal comfort di sini dikembangkan mulai oleh Hamper dari tahun 78, mereka mengadakan suatu research di beberapa negara. Ternyata mereka mendapatkan suatu data untuk iklim-iklim yang berbeda, terutama iklim-iklim yang daerah tropis, itu kenyamanan temperatur di dalam ruangan itu bisa lebih tinggi dibandingkan dengan temperatur yang didapatkan dengan conventional thermal comfort yang dikembangkan tahun 81. Nah, sekarang ini hampir seluruh dunia termasuk Singapura dan Malaysia, Australia itu sudah mengembangkan suatu standar adaptive thermal comfort. Di China itu mereka membagi menjadi 5 area untuk adaptive thermal comfort. India itu membagi menjadi 4. Jadi negara-negara yang lain itu juga sudah mulai berkembang. Nah, ini adalah yang ungu. Ini kelihatan nggak, Bu? Kepotong ya?
Kelihatan, Pak John?
Kelihatan ya?
Ya.
Jadi untuk thermal comfort itu temperaturnya adalah di range di 22 sampai 34. Jadi saya kasih kotak warna ungu itu. Nah, ini adalah untuk tropical climate. Nah, kalau misalnya kita lihat grafiknya di sana itu, maka kita bisa mendapatkan temperatur ruangan di sana itu tetap 28 atau 29, tetap nyaman. Ini bagaimana kita bisa mendapatkan, yaitu kita menambahkan suatu fan, suatu kecepatan udara di dalam ruangan. Nah, ini adalah warna hijau ini adalah untuk yang natural ventilation, karena adaptive thermal comfort di sini ini memasukkan unsur udara luar, yaitu unsur udara di dalam luar kalau bisa kita memasukkan dengan memakai natural ventilation. Akibatnya apa? Akibatnya kita bisa menaikkan room temperatur tidak seperti konvensional thermal comfort. Akibatnya apa? Kita bisa saving energi besar sekali. Nah, tadi konsepnya di sini adalah healthy dan saving energi. Kita mendapatkan healthy karena kita mengintroduce udara luar, berarti kita memasukkan O2 yang dibutuhkan oleh orang di dalam, dan juga mengurangi konsentrasi CO2 yang ada di dalam ruangan tersebut. Sehingga kita akan mendapatkan suatu kondisi yang healthy di dalam ruangan tersebut, sekaligus kita mendapatkan energi yang lebih kecil. Nah, ini adalah paper yang kotak saya kasih warna merah di sana itu adalah kotak-kotak untuk negara-negara tropical climate. Contohnya adalah Bangkok. Nah, di sini Bangkok di sini kalau kita memakai AC, maka temperaturnya adalah 24,5. Tetapi kalau misalnya kita memakai NV, yaitu natural ventilation, kita bisa mendapatkan room temperatur 28,5 derajat Celcius, tetap kita merasa nyaman. Lalu
Time is up,
Debil,
Pak John.
kenapa?
Time is up for you.
Oh,
would you mind to make it short?
Oke, ini adalah mengenai thermal comfort. Nah, ini adalah S3 standard, jadi kita bisa memakai 28 atau 29. Mungkin saya yang terakhir aja untuk Indonesia di sini. Nah, Indonesia ini termasuk daerah tropis. Bagaimana kita mendapatkan natural ventilation-nya itu? Kita bisa mendapatkan, karena natural ventilation itu ada 4, yaitu cross natural ventilation, buoyancy, stick effect, ventilation, solar-induced ventilation, dan wind-induced ventilation. Karena Indonesia adalah tropis, maka kita bisa memanfaatkan solar-induced ventilation. Nah, ini adalah konsep yang kita pakai. Ini adalah salah satu contoh kita memakai solar-induced natural ventilation dengan stick effect. Lalu saya akan tunjukkan masalah, ini adalah rumah saya yang memakai natural ventilation. Nah, ini adalah kita memakai yang disebut skylight solar induced natural ventilation, yaitu kita membuat kompartemen dari kaca semua. Di sana kita memberikan kaca bening sehingga mendapatkan sinar matahari. Akibatnya apa? Kompartemennya di sana itu mendapatkan temperatur itu delta T-nya itu sekitar 8-15%. Akibatnya apa? Ini contohnya adalah 39,9%. Jadi temperaturnya kita naikin sehingga delta T-nya lebih besar sehingga induce ventilasinya. Ini adalah gambar yang kita mendapatkan natural ventilation. Di sebelah kiri adalah untuk lantai 1, kecepatan anginnya kita lihat gordennya. Di tengah itu adalah lantai kedua, kita mendapatkan kecepatan anginnya. Di yang paling sebelah kanan adalah kecepatan angin yang kita dapatkan. Ini semuanya
Thank you, Pak John.
disebabkan
Time
karena,
is up.
ya. Thank you.
Yeah, I'm sorry, Pak John. But we have your movement. Thank you, Pak John.
Okay.
I'm so sorry to stop your presentation, Pak John, because due to the time. But we have the committee have the full presentation of you, and we will share the presentation to the participant. And next, I would like to invite our last speaker, Anne Svensson, to come to the stage. I hope I haven't spelled your name wrong, Anne. And Anne will talk about net zero building, which is a very prominent issue lately. Anne, please, time is yours.
Thank you very much.
Yes.
Can you see my screen?
Yes.
So thank you very much, Ibu Farida, and thank you very much to MASKEEI for inviting us to this very good and big conference. I hope that this can be an inspiration to some of your projects and what you're doing, and I'm very honorable to be joining here today. So my name is Anne Svensson. I'm working for the Danish Energy Agency, and I'm working with energy efficiency in buildings. And also thank you to the previous speakers. Now, Pak John, you were talking very much about the tropical countries, but that inspired me to give you a little bit of fresh and cold air. This is from the winter here in my country, in Denmark. But maybe it's kind of a good picture, because here we have the saving I don't know what this is called, but maybe this is the one we need to throw out to people to save everybody, just for inspiration and a little bit of coolness. So I'm located in the country, Denmark, very far away. We are not having issues like tropical countries like you. We have a cold climate. Our major issue is to keep the heat inside the buildings in the cold winters, whereas in your country, it is to keep the heat outside of the buildings. And we're very well aware about that. Our solutions can, of course, not be used directly in your country, but as I say, maybe it can be used for inspiration to some of the things you're working on. Just to inform you about our climate targets, the important one is that we have set a greenhouse gas reduction target for 70% compared to 1990. That in 2030 we will reach this target. At the moment we are at 45% reduction, so we are on our way, and we know that it's a very ambitious target, and we know that we have technologies for reaching, say, 60% reduction by 2030. We know that the last 10% will be a very big challenge, and we also need inspiration from other countries and other places. About buildings, we are part of the European Union, so we are under the European directives on energy efficiency, and one of the requirements in this is that all countries have to focus on developing net zero energy building strategies. And in Denmark, we have decided that from this year, all new buildings must be net zero energy buildings. I will get back to what our understanding of this is, because there's a lot of very different understandings on what nearly zero or net zero energy buildings consist of. So, but we still have a lot of challenges in Denmark. We have the existing building stock. We only build the building rate is only about 1 or 2% new buildings per year. Many of our old buildings, now, of course, I have included a very nice picture of some very old buildings. They're not all like this, but many buildings are 50 or 200 years old, 50, 100, 200 years old. And they are built in a way and constructed in a way that it's not just easy to renovate them. It may not be possible to install insulation on the outside of the building. There may be some restrictions and so on. And it may also be difficult. There was a talk from Pak John about ventilation. The old buildings are not built with ventilations, but when we put in insulation, the buildings are more tight, and then we need ventilation, but it might be difficult to get the pipes and ducts and channels and so on through the old buildings. So we do have a lot of challenges in this. We also recognize that there is a need for what we call deep renovation. So that's where we go really deep. We do insulation, we do window replacement, heating system replacement, and ventilation system. These issues or these activities have very long payback periods, so it's difficult to get the building owners to do these deep renovations without having funding opportunities. So what do we mean with, as I say, net zero buildings? Well, first we have the building sector accounts for about 40% of the energy consumption, which is about 30% of the total CO2 emissions. But we use the energy in the buildings for heating. As I say, it's a cold country. We need to keep the heat inside of the building. We need to heat up our buildings. We have the use for production of hot water, ventilation, pumps, automation, lighting. I have put like cooking ovens, freezers, refrigeration, washers, dryers, and so on in other, because this is not really what we are regulating on from the Danish Energy Agency. This is regulated by the eco-design system, where all equipment, all appliances have to be labeled. So this is more up to the building owner themselves to get good and energy efficient appliances. So somebody would say, well, couldn't we just wait for the energy production to be CO2 neutral? We do have a lot of district heating for our buildings. So the district heating is produced in large power plants. Can't we just wait for this to take place, the transition? And this is, here you can see the CO2 emissions from power plants in Denmark. It's going down. So why don't we just sit back and wait? Everything will be solved for us. But we cannot do this. We still need to take active position in the climate footprint when we build, renovate, and operate buildings. So we cannot rely on the improvements in production. We do need to look at the buildings also. A little bit about the building codes system in Denmark. The first building code with energy requirements came in 1979. This came as a result of the energy crisis. We were forced to do something to reduce energy consumption in buildings. Before that, there had been very little consideration on energy consumptions. But as I said, there was the energy crisis, the worldwide energy crisis at that time. So we had a start. In the start, it was only prescriptive building code saying requirements for the U values, the windows, and so on. In 2006, we changed this also to be performance-based building code, where we say that there are still requirements for the U values for walls and roof and windows and so on. But there is also an overall energy performance requirement that each building have to live up to. And our building code is also, they're also valid for renovation of buildings. So this is the development in the requirement. As you can see, we have, if there is a building built before the energy requirements and a building built today, it's a very big reduction in the energy consumption. So this is just to inspire you to say that if you are actually working on building codes, it does have an effect. As I said earlier, it's only for the new buildings, so it goes very, very slowly. But the buildings you're building today, they last for 50, maybe 100 years. So the sooner, the better to include requirements on new buildings. So for nearly zero energy buildings or net zero energy buildings, the term is a little bit different, whether you say, is it the building not emitting any CO2 on the site, or is it the building in total not emitting any CO2 from energy production, or so there are some differences on how this is interpreted. But what is important is that it's a building with a very low thermal loss. So in our case, it's insulation. We have focused on the insulation in the roof, the walls, and also the floors. In your case, it would be the same, because you would need to keep the heat outside of the building still. It's a very high focus on the performance of the windows, not only using triple glaze, that's also used in some places, but also working very much with the solar heat gain coefficient, how much heat is coming in through the windows, reducing the thermal bridges, improving the airtightness of the building. So we have very, very strict requirements on how airtight the building can be. And this has to be proven by a blower door test when you're doing constructing new buildings. We also have very big focus on reducing or ensuring solar shading on windows. So like first to reduce the solar coming into the house, and then working on either ventilation or cooling. And also we have a focus on using renewable energy in the buildings. So again, back to the building code, we have a requirement for the thermal loss. It's not quite comparable to the overall thermal transmission value that is used in Indonesian building code, but it's the thermal loss through the building envelope, and there is a maximum of 4 to 6 watt per square meter. Then, as I say, we have the performance requirement, and that's about 30 to 40 kilowatt hours per square meter. So that includes the heating of the building, the ventilation, and the production of hot water. It depends whether it's a residential building or a public or commercial building. In our building regulation, we then have what is like a step code. So we have the requirement, and then yet there is a voluntary step that you can go for, and that's where you have to have 20 kilowatt hours per square meter for heating, production of hot water, and ventilation. So what do we mean with buildings have to be supplied by renewable energy? In our country, it means that you're not allowed to install oil boilers in new buildings. Heating from district heating is considered to be renewable. You could argue and say, yeah, but that depends on what you are burning in the power plant. But we have changed all our power plants from coal. I think we have one power plant left going on coal, but it is being phased out very, very soon. So at the moment they are going on biofuels or wood, and that's still an argument saying is that then CO2 neutral or not? But we're working on our way to this. Heat pump is considered renewable because we have very high number of windmills. We have about 45% energy coming from windmills in the electricity system. So also if you have wind power or solar energy or geothermal energy on your own land, it's considered as renewable. The building code we had was revised in 2018. So our next building code will come in 2023. So we have a 5-year cycle on this. And as you could see, we are very low on the energy demand. So it's very difficult to go further. It doesn't make any sense to make requirement on more insulation and better windows and so on. So what we're looking at in the future is to include documentation of embedded energy or embedded CO2 in the building materials. There is now a requirement, or there will be a requirement in the next revision, that in the construction and the lifetime of the building, the CO2 emission cannot be more than 12 kilo CO2 per square meter of the heated area of the building. And maybe you say 12 kilogram is what is this big or low, but from our calculation, it should be possible for all buildings at the moment to fulfill this requirement. So it has been set rather high just to get people into the habit of doing this calculation and documentation. And then it's also said in the regulation that for the next revision, this threshold will be lowered. And we have yet to see how the building industry is going to adapt to this and how they are going to do the documentation, because in order to do this, we need a lot of information on the CO2 emission on each building material. And this could be the topic of a whole other workshop, because how do you do the documentation and how do you collect it? We're working on a national database where all the information will be stored, but at the moment it's still very experimental and we're a work in progress. Which other things will we be including? There will be requirements on the flexibility and efficient use of the building. Circular economy is involved. There will be a requirement of the production of a life cycle cost analysis for this. And as I mentioned, there is now already the requirement on embedded energy in building materials. There's a strong focus on the documentation of good indoor climate. Again, Pak John, you mentioned all the requirements for a good indoor climate. Here we are also focusing on actually documenting that you are achieving these the different parameters that was mentioned. There is a focus on reducing the number of volatile substances in building materials. Very strong focus on the reuse of building materials. This is another topic because then you have to have a lot of documentation on the the performance of the building materials. We are thinking about including requirements for sustainability certification. We are in Denmark, we are using the German system, the DGNB system. So at the moment, it is not required to have a sustainability certification of the building. It's a voluntary thing, but we are considering this to be a requirement also. So at the moment, the Danish Energy Agency is supporting a trial phase where we are seeing if the building industry can live up to these requirements. Because one thing is to put requirements, but if they are not, if it's not possible to fulfill them, or if they are too strict, or it's not going to happen. So we're working closely with the building industry to see if they can actually fulfill this. So we are supporting some test projects, about 30 real building projects where we are supporting the developers with money for the documentation phase. And of course, as you all know, the building industry will be very reluctant in the beginning, but when we are offering them a little bit of money for this extra work, they usually go into it, and then we get very useful response on these requirements. So this was actually all I would say today. I hope that I have given a little bit of inspiration, and you're all very welcome to have some questions in the Q&A. Yes, so thank you.
Thank you, Anne. New insight related to this cutting-edge initiative. Very interesting to hear from you, and I hope this can also inspiring us in not only in Indonesia but also in the Southeast Asia, how to combat with our effort to continue reduce the emission in each country. So now it's time for us to have a Q&A session, and I see there is a question comes to Pak John. To Pak John, then Pak John, can you see Pak John?
Yes, I can see.
Yes. So you would like to directly answer the question?
Okay. So I answer in bahasa. Okay.
Yeah, please, Pak.
Ya. Oke, terima kasih. Jadi kita bisa menerapkan SD mengusulkan bahwa dalam keadaan pandemik COVID-19 ini, minimum udara ventilasi, udara luar yang kita masukkan, itu adalah 2 kali ACH. Nah, problemnya sekarang, kalau misalnya kita memasukkan udara luar kita ini adalah panas dan lembab, dan kadang-kadang di kota-kota besar itu polutan. Maka untuk mengatasi ini, maka kita perlu memakai DOAS. DOAS itu apa? Dedicated Outdoor Air System. Jadi udara luar yang 2 kali ACH itu, sebelum kita masukkan ke dalam ruangan, kita mendinginkan, dikelola, dan dikondisikan dengan DOAS, temperaturnya kita turunkan, moisture content-nya kita turunkan, serta kita filter dengan memakai NERV 14 atau 16, atau European Standard memakai F9. Nah, itu yang kita akan bisa mendapatkan tetap nyaman dan sehat, serta tetap hemat. Itu jawaban
Oke,
saya.
Pak John. Terima kasih, Pak John. Terima kasih. So I have a question to Anne. Indonesia and also other Asian countries, excluding Singapore, I guess, also have difficulty to motivating building owners, especially owned by the government, and to apply the green building concept. The main obstacle is funding. Do you think the ESCO scheme can be a way out?
Thank you. I think ESCO schemes are very relevant for Indonesian countries. We have some experience from our country, especially for municipal and public buildings. The challenge in our country is that if it's for public buildings, they normally have a 1-year budget, whereas an ESCO project goes for say 10 years or something. So it's difficult to put into our financial structure. The other thing is that most of our municipalities, they can borrow the money in the bank to better interest rate than through ESCO systems. So it's not like the real financial ESCOs that we are working with. But the projects that have been there, they have a good success rate, because then they can include more things than normally in public buildings. The budgets are very, very limited, and we see that it's normally only sort of acute renovations when things break down and so on. We don't have the what we see in ESCO project is a more holistic approach and a more long-term approach. And I was talking also about this deep renovation. So when you can combine several measures, energy-saving measures, it makes very good sense to say we have an old ventilation system. It may have a payback period of 2 years to replace that, but we also need insulation on the roof that has 40 years payback. But if we put these two projects together, maybe we have then 5 or 10 years payback. So I definitely think it's a very good way forward, but you have to think about the financing and so on also.
Yeah. Thank you, Anne. Thank you. And next, my question goes to Yoga. Yoga, most of the case happen in the country like Indonesia is how to follow the international initiative and in application. How you see this situation, harmonization, national and international law, regulation and policy?
Thank you for the question, Ibu Farida. Well, the way in which the harmonization can be achieved is, first of all, there needs to be some form of national law or regulation that's passed that then can be fed right through the different levels of government, so different levels of sub-government. Another way of also doing that is through having demonstration projects that are aligned with some of those imperatives that Anne and Pak Sujamoto and Pak John has talked about. And those demonstration projects can actually be projects whereby it provides the baseline studies for what's really needed to inform government at the national level, but also really at that local level in terms of how to policy make in this space. So there are two ways I think of how we can do is, one, the national level. And if you noted recently in Indonesia, for example, you had the omnibus law that was passed. And the omnibus law has enabled, well, will perhaps enable for more national intervention in the context of regulation, so it's more consistent from national to sub-national level. That's hopefully, that will then enable the consistent application of international law to the Paris Agreement and the NDC target that Indonesia needs to achieve. Otherwise, please promote and support demonstration projects that a lot of the international bodies are trying to work with, especially with the private sector and also with various supply chain and local governments, because that is how you see the dial move in policy making in this space.
Thank you. Thank you. Pak Surjamanto, actually I have a question for you, but time is up for us, Pak, and the next session will be come to begin. And with all due my respect, I would like to close this session and Ladies and gentlemen, now we are approaching end of the session, and I would like to thank for your contribution in this forum, as well as my high gratitude appreciation to the speakers who have been willing to share their knowledge and experiences with us. I'm sure that we have achieved today, that what we have achieved today will make a positive contribution to our collective efforts to keep trying to manage our environment through the implementation of energy efficiency in our lifestyle. Again, thank you very much for the to Pak John, Anne, Yoga, and Pak Sudarmanto to your contribution and sharing your experiences in this forum. Thank you very much, and we close the session.
Thank you and goodbye.
Bu Farida, terima kasih.
Terima kasih.
Thank you and thank
Sama-sama.
you.